So, good morning, ladies and gentlemen. It is my honor and pleasure to present to you on the topic of feature engineering for IoT. So, after my presentation, I'll pass over my time to Boon Kui, Chief MTech Software Engineering Program, to share with you on the MTech Software Engineering program. So, the Internet of Things refers to billions of devices around the world that are connected to the Internet, connecting, sharing data, valuable insights, predictions, and actions. So in today's world, we see a number of in the rise a number of connected devices in various industry verticals, such as gas and electricity, steam and aircon, home automation, water supply and waste management, automotives and industrial IoT, growing in the various segments in autonomous vehicle, IT infrastructure, asset tracking and monitoring, and smart grid. Sensor and sensing technology has emerged as the primary enabling technology for a wide range of applications over the past decades and will continue to contribute to the core component of future technologies such as multimedia, AR/VR, which are immersive systems or technologies, the Internet of Things, control systems, and cross-disciplinary applications for pattern recognition and artificial intelligence. So when we look at the reference architecture here, we think about the primary purpose and workflow of IoT solutions. So it involves the things, the insights and actions. So things are devices that generate data. Data forms the insights, and based on the insights, you can be a manual automated decision to trigger or execute certain actions. Therefore, the entire purpose of IoT is driven by data, producing event-driven or data-driven architecture with the addition of data management service such as Gearbox Edge Suite, Springboard applications. So with the accelerator of cloud services, so it is designed to meet regular enterprise requirements and complexities of industrial connected product system. So looking at it, where is the importance of data? So it is primarily data. So in the next couple of slides, we are going to go through a simple example and some techniques of machine learning to extract features out of IoT data to produce valuable insights that contribute to valuable actions for building intelligence feedback autonomous systems. So essentially, when we look at cloud services, it is a pie in the architecture of IoT. We see capabilities added to form the downstream or edge devices. So gateways are used to authenticate and communicate with downstream devices, downstream heterogeneous devices, and the increased usage and adoption of cloud services. So with increased device connectivity and data, we see a shift from cloud-centric in terms of storage and processing pattern to a more device or gateway-centric pattern. So this strategy is powerful for operating large number of devices at multiple locations. So we have volume, right? We see that there will be rapid increase in volume of data with cloud computing IoT devices. And then we can see the velocity with increased speed at which data are getting accumulated. And there will be a variety of data coming in with increased market players. We have seen a variety of structured or semi-structured sensor data and the unstructured data that are due to the different source coming or generated by humans or machine. And we see in terms of veracity, we can see that data are collected from multiple sources, and we need to check the quality, integrity, credibility, and accuracy of the data before using it for insights. And for value, then and now we can garner value out of the insight that are produced by the data for decision making. That is why data preparation framework comes in handy. Firstly, we look at data discretization, where we look at discretization or reduction of data by converting continuous numerical data into discrete bin that forms 1 and 0 rather than continuous form. Number two, we look into data cleaning. Then we look at how we handle missing data or values or erroneous value that could be due to interruptions of data flow, etc. Number three, we have data integration, that you have reference other data sources with existing data to come up with new features or improve model for better prediction. So with necessary or relevant combination of the data sources, it may bring better accuracy, improve performance to insights and decision making. Number four, we have data transformation. So after we clean up the data, we need to summarize and present it in a perspective that can make sense of the data to give insightful reporting and decision making. And last but not least, on data reduction, we can further reduce the data to produce similar analytical results. So we just look at the consolidation of data from multiple sources to the cleaning of data to ensure the consistency and, and completeness of the data for AI model training and accuracy. So in the next couple of slides, we're going to go through the details of the process of feature engineering. So we need a lot of data for machine learning models to learn from. Data collection can be a large part of the effort in machine learning projects. So there are different types of data that we can work with. So we have historical data that we have been generating through the years, such as past weathers. We can use such data to predict future weathers. And a lot of data are also generated by external systems, right? Devices, for example, the temperature, humidity, precipitation data from sensors deployed geographically. Data can also be collected manually. For example, whether a geographical region is sunny, raining, or drizzling. Data can be input by different personnel who provide information to a central platform during different time of the day. With that data, for example, we can run a simulation to determine if a region is having wet or dry weather and whether user can conduct events. So this will allow us to infer its probability distribution in the real world. In a probability distribution tells us the likelihood of a possible outcome or events in a situation where we have yet collected enough data or do not have time to do so. And we can actually generate usable data from probability distribution, that the generated data can rather be close to one that we have collected in the real world. So feature extraction aims to reduce these features in the dataset by creating new features from the existing one or discarding the original features. This new reduced set of features should then be able to summarize most of the information contained in the original dataset. Right. And this feature extraction in the process of extracting features from a data or a set of data to produce useful information without distorting the original relationship of the significant information. The compressed amount of data into manageable quantities for algorithms to process. The purpose here is to make sure that we prepare the data or we clean the data, and data then can be used to create a good model to improve the accuracy of the model, to minimize overfitting, underfitting issues while learning through the AI, and improve the data visualization. So two approach that we're going to talk about subsequently will be about feature extraction, which is reducing the number of features in the data set. That means discarding the original features, and reduce the set of features to form a summarized features from original features. And number two that we're going to talk about will be feature selections, right? Discarding less important columns where there are no new features that's been created in the next couple of slides. So a sample here or observation here shows the value or set of values of the interest. So in practice, it is usually a row of features in a table. And the features is any attribute, example, precipitations or temperature of our data set. So in practice, feature is a column of value in a table. And label is any attribute that identifies a sample to a specific class. For example, look at the last column here, we have weather, and then whether it's drizzling, raining, or sunny. So when it comes to preparing your data for machine learning, we look at missing values as one of the most typical issues, and they have huge performance on the machine learning models. Human errors, data flow interruption, privacy concerns, and other factors could all contribute to missing values. The goal here is to imputate them, right, to handle how we handle these missing values. Right, we have ways to handle them, right? Which is numerically, we can figure out what numbers should be assigned to the missing value currently in the data set. We usually use an analyzed set of data from complete set, and based on trends and pattern, right, we fill in the gaps with certain information. So in this case, we fill in this value with missing value with the value of 0. Okay, next we can have category data, or how we handle category data, right? Which is we replace values with the highest value in the column. And if you believe that the values in the column are evenly distributed and that there's no dominating value, so imputing a category like others would be a better choice. We will also need to remove outliers from the data set. This is especially important to produce a more accurate data representation to improve the performance of the model used for training. So to improve the performance of the model used for training, some techniques could be used to remove the outliers. Okay, this includes removal methods where we remove entries of the data set. So this technique is not advisable because if there are missing value across numerous common data set, there will be a lot of missing records. Or we could also replace missing values with a suitable imputation. We could also use capping technology where we use arbitrary values or a value from the distribution to replace a maximum or minimum value. Discretization is important here, where we convert continuous variables, models, and functions into discrete values such as 1 or 0. So in particular, when we look at the same set of data, we could apply binning, right, on the numerical data or categorical data and put them into two bins. Records with precipitation as highlighted above, right, in yellow in one bin, and records without precipitation in another bin. So binning here will help us reduce the cardinality of continuous and discrete data and group them into related values together. So this will improve the utilization of the resources and to build a better model, right? Quality in training. Feature selection is to pick up the most representative features to use for over machine learning algorithms. The selected features here are from the assisted features in our data sets. There are new features being generated. So in the feature selection, so number one, we could actually select the features that are highly correlated to our target label. And then with those selected features, we look for sets of features that are highly correlated among themselves. Number two, features that are highly correlated to each other may convey the same information to our learning model and are therefore redundant. And number three, in the set of highly correlated features, we actually select the one that has highest correlation with the target labelers. And the one with the highest correlation should convey the most information to the target that we are looking for in our learning model. And then with the selected one, we can use in training or learning the model. So this is feature selection in the process of selecting subset of the relevant predicting features to be used in our machine learning model. So a way to find out the relationship of selecting features is to find out the relation between two features. For this, we could use the most common correlation method, which is Pearson correlation. So firstly, I would like you to understand what we meant by correlation. So it refers to how two numerical variables relate to each other. So we could have things like if one change, another should change, right? If one increases, another increase. If one decreases, another decrease. So firstly, we have positive correlation. It refers to the extent to which a variable increases, another will also increase. So we call this direct proportional, right, correlation. So example would be if a temperature goes up, and ice cream sales will also goes up. So when we look at negative correlation, it refers to the extent that when one variable increases, the other will decrease. So an example will be if the temperature decreases, people will likely purchase heaters and install in their homes. So for weather data set here, we could also use exploratory data analysis, EDA, to perform investigation on the data so as to discover patterns spot anomalies, and test hypotheses and check our assumption, and with the help of statistic and graphical representation. So with data sets, we could plot the 3D visualization weather condition as shown here on the left, right? We see that there is a clear separation line in the plot which distinguishes rain condition and sunny condition. The blue dots here, it shows that it is a rain condition where the amount of precipitation increases. Whereas for the red dots, it shows it didn't rain or the amount of precipitation is lowest. So if you calculate the correlationship between the variables, precipitations has a significant correlationship with the rain variable. So feature extraction works by analyzing the feature in our data set so as to generate a new set of feature through some form of dimension reduction, like principal component analysis, PCA, which is actually doing some form of data transformation. The new set of data retain much of the information of the original features, but the dimension of the new features have been much reduced or smaller than the original feature. So in this diagram, you can see the number of features we have on the left from 5, we have reduced to 3. So feature scaling is a method where we scale number features in the same scale and range, like -1 to 1 or 0 to 1. So this is the last step involved in data processing and before machine learning model or training. And we call this normalization. So we apply feature scaling on independent variable. We feed feature scaling with trained data and transform them with the trained and test data. The scale of the raw feature is different according to its unit. Machine learning algorithms here will not be able to understand the feature, therefore they only understand normal. So there's two types of normalization that we can apply. So number one here, we can see that we can apply normalization. Basically, it's going to rescale the feature into a fixed range between 0 and 1. So normalization, we can also have things like min-max scaling. So if data doesn't follow normal distribution, which is Gaussian distribution, or whether number two, we could use standardization to rescale the feature, where we have things that will produce the mean or the standard deviation from the set of data. So the result of standard deviation is usually z-score normalization to produce a normal distribution or Gaussian distribution. So there's no thumb of rule to use in whether we use normalization or standardization, but mostly in such data sets, in whether we will use standardization, where we can later perform cluster analysis or principal component analysis. So we have looked at about the feature engineering and part of the solution, and which is really about collecting data. All right, and we look into sampling, right, where we split the data set into train and test data set. So 80% of the data set will be used for training and the remaining 20 used for testing, right? And then we can later use it to build a machine learning model, right? The trained data set is passed to a linear regression algorithm in this sample or in this example for training, right? To produce a trained predictor or trained model. So this can be using code like Python with sklearn library to accomplish this step. And then we have to test the machine learning model. And after the training data set is passed to the predictor model, right, it will tell us whether the model is under attack or it meets evaluating criteria when we evaluate the model to determine the accuracy of our model being generated, right, using some form of confusion metrics and accuracy parameters to determine the performance. Okay, in summary, the objective of every machine learning model is to predict the value of a target variable using a set of predictor value. So feature engineering improves the performance of machine learning by selecting the right features for the model and preparing the features for machine learning. So the 5 key steps involved here to produce you with insights regarding feature engineering decision includes number one, data cleaning, where we process deal with erroneous or inconsistent data, like identify incorrect, missing data, duplicate data, irrelevant data, right? Deleting them or replacing them or modifying them to remove outliers and incorrect values. right? And then we transform the data, right? We have some form of a process of transforming the data from one layout to another, right? We have things like standardization, converting the data into a uniform format, or encoding, right? Converting data from category to numerical variable. And then we move into extracting them, extracting the features, right, from extracting existing attributes, primarily concerns with reducing the number of features in the model, right? And then we try to select the features, selecting the correct subset of features to ensure that the most relationship with the target variable, eliminating features that do not explain the behavior of the target variable. This can be done by ranking the features based on statistical tests or identify the most important features. So one of the methods that we talked about earlier to do that is Pearson correlation, right? And last but not least, we iterate this feature, right? Iterate the process involving the step above, right? Putting into some machine learning algorithms with selected features to train the model to produce a trained predictor model. And then we can measure the performance. And then we go about how we can get the best decision out of it to remove the selected features. So with this, we have completed our module or topic of feature engineering for IoT. Please also help us give a feedback on our program through the slides here. All right, and it's Q&A time. Do you have any questions regarding this topic? I have a question here where a participant asked about how do we define quality data. So in quality data, especially from IoT, we have data from sensors and data that be corrupted from the environment. So upfront, we have to do some analysis, and where there are missing data or data that are way out beyond the original value, the system should or the services that we use, for example, if we pass the data into a event-driven system in Kafka or in the cloud in analysis, analytics, synaptics, you should have some form of code there to remove missing data or to handle missing data. All right, you have to clean it. All right, before you can pass it to make sure that those are good data that can be used for training. Of course, this come from experience and over time, right? You will improve the way you process, handle or missing data. As about the question where we talk about, is there any non-numerical data in machine learning, right? There was a part, right, where I shared in the earlier phase where we need to do data cleaning. So this can be categorical data, right? Things that has certain form, like it's raining, like it's drizzling, or it's sunny, right? We can categorize them into numerical values because machine learning may not really understands non-numerical digits. So you have to try to categorize them, right, into certain category, and then later on you can use it to pump into certain algorithms such as regression, right? In our case, for whether we can use a simple regression algorithm for training. All right, so feature engineering is primarily the early part of data preparation before we put them into training so that we can use it as a predictive or preemptive analysis in certain cases in IoT. Okay, I have a question that come in that talk about how do we balance between modifying data versus potentially turning into desired machine learning outcome. Okay, so this part, right, when we talk about IoT, is really not, it really involves different ends, right, from a software developing end to data scientists and machine learning scientists. All right, so we may need even data scientists or machine learning scientists to come in to look at the data set clearly first, right, before we can impute, right, what code that we want to put in, right, in the live streaming analytics of this data, right, for live cleaning of the data. All right. Or alternatively, this data can go in and store somewhere as a batch in some storage. And then from there, we do a post-processing. That means a delayed processing, which ultimately it can become past data or historical data for machine learning to learn and process also. Okay, so I hope I answer your question. we have about 2 more minutes. So to share more, basically, this is in IoT, right? Is if you look at a Siri, right? For example, where we have text analytics, they impute those value, right? So that you notice now in your phone, smartphone, where you uses those voice recognition or voice speech, right? It is more accurate, right, to translate text to speech or speech to text over learning, and it can these are data that are collected. So similarly in IoT, you have to collect data, right? And then you have to analyze this data, all right? And to make sure that whatever the machine is going to learn, right? Or when the machine do feature engineering part to clean up the data, to extract the features, right? It matches with your human manual way of cleaning or processing the data, all right? And subsequently, you can trust all these algorithms, right? In fact, you should trust this algorithm, right, to help you do a better job, a more efficient job in processing this data. All right. And after that, it will pump into the various machine learning language, which actually I will talk more about what type of machine languages to use, right, in IoT for different type of data that come in. So, for example, images, we will likely be using things like image classification, convolution neural network, right, for image processing and image classification. All right, neural network is a part of which is very important when we deal with images data for IoT. And for data that are non-images, right, we may use more of a neural network or reinforcement learning. So reinforcement learning is something that is also pretty important in the area of IoT. So do you have any other questions? All right. So if not, I will pass over my time to Chief MTech Software Engineering, Heng Boon Kui, to share with you more on the software engineering program that we have in ISS.
Okay, thank you, Dara, for the interesting discussions on IoT. Yeah, so if you need to contact him, here is his email address. Yeah, so this is Boon Kui here. Before I start with a brief intro or preview of MTech and software engineering, we actually need a little help from you to let us know a little bit about your opinions about IoT. Okay, so we have a quick poll here, just 3 quick questions. Yeah, so you can see on the screen and also in the chat message, there should be a link. Yeah, so please help by either using your mobile phone or your computer to load this URL. Okay, so the QR code at the side is also pointing to that. Yeah, yeah. So please start with the first. This is the first question, the one that you are seeing. Okay, and we want to know if your team has already started with some IoT projects. Yeah, and this will give us a good idea of the current adoptions of IoT in your organizations. Yeah, thank you so much for those who responded. Yeah, and we can see that the the majority are still not uh, adopting IoT yet. Okay, so we will give a little more time for this particular questions before I move on to the next one. Okay, so thank you so much for your responses. And here is the second question. Okay, a little bit slightly more complicated. So if you are doing IoT projects, we want to know what sort of processing do you do on the data that you have gathered from IoT devices? Yeah. And please indicate which is the most sophisticated processing that you are doing. Yeah, so the lower you go, okay, so for example, A is you are not doing anything. Yeah, and E is the most sophisticated one because you are applying machine learning. Yeah, and then in between, for example, B is about you just store your data and hopefully they could be useful in future. Yeah, and C, you are doing traditional business intelligence. Yeah, so you are sort of analyzing the past and current events. So, for example, what are the top 5 best selling products in the past week, for example? Yeah, but you don't predict the future. So, if you predict the future, that will go to D. Okay, so yeah, so that's what we mean by the different level of sophistication. Yeah. Okay, so we can see that none of you had actually done machine learning so far, okay, which is E. Yeah. So then I would think that given the potential benefits of using some machine learning model to help you in automating decision making, uh, I we suppose there is a good potential uh, to improve that, and of course that might require some training as well. Yeah. Okay, so we will give a few more seconds for you to respond to these questions. Okay, so thanks a lot for your responses. And now we get to the last questions. Yeah. So if you think uh, your organization would need to somehow move on to the more sophisticated processing of IoT data, for example, applying machine learning. So, what do you think? I mean, do you think your team would require some training in the form of a course, short course like a 3 to 4 day course, or do you think your teams can actually pick up the skills by themselves? Uh, because you might rely on reading a book, watching YouTube videos, and so on. Okay, or C, you are not sure even if such skills are needed or not. Yeah. Okay, so thanks a lot for the responses. And then let's give it 3 more seconds. Okay, many thanks to your responses. Yeah, so I'm now moving on to a quick or brief preview of Master of Technology in Software Engineering. Yeah, so and I can't be elaborating them. So if you need further details, certainly you can contact me as well. So for MTech SE is actually a practice-oriented program. Okay, that means as compared to computer science, which focuses on, for example, the science aspect. Okay, but for SE, we are focusing on the practice-oriented issues. For example, on how to build software, how to collect requirements, how to conduct agile practices, software design, software architecture, and so on. Okay, so the main focus of our program would be on software design as well as architecture. Yeah, and we focus on building distributed system in various forms. Yeah, and whether it's just a software system or even the software platforms, which is a newer concept nowadays. Yeah, or even as a product portfolio. And we believe that we need our students to be equipped with skills on building scalable systems that can incorporate smart components. So, for example, interfacing with machine learning model, okay, or maybe tap on the predictive analytics. Yeah, and they need to be secure as well. So that is especially important. Yeah, and the program also cater to specialization. So for example, after learning all the basic stuff, you want to specialize more on product management. So we have such focus or more on managing platforms. Yeah, okay, or dealing with intelligence in particular, like what Dara had explained earlier, in terms of IoT, processing the IoT data, yeah, and also big data, okay? So, and how do we deal with that? We have a series of so-called graduate certificates or MTech SE. So as you can see, every vertical columns here is a graduate certificates, yeah. And for the program, effective from January 2023, we have 2 foundation certificates, okay, and then which are mandatory for all students, yeah, and we have 4 specialist certificates, where each student will have to pick 2 of them, yeah. So what is a graduate certificate? Taking the first one, designing modern software systems, yeah. So it comprises a few courses and a practice module. Okay. So that is always the combination. Yeah. And if you look across, you get a good idea. Yeah. And for every student that enroll in the graduate certificates, then these courses would have to be attended. And for each course, there would be some in-course assessment. Okay, so they got to be submitted for assessment, but they are not graded. So how do we do grading for each graduate certificate? That is through the practice module here, which in general can be comprising of a practice project and also a written exam. Yeah, but for some of the certificates, the written exam is not is not uh, is not required. That means we will rely fully on the practice project. Yeah. Okay. So from here you can see for each graduate certificates, every student will get a grade. Okay. So so if you take 2 foundation certificates and 2 specialist certificates, you will have 4 grades. Yeah. Okay, and then in order to complete the MTech SE program, you also need to do a capstone project that I'm not showing here. Yeah, so essentially you need to do 4 graduate certificates and 1 capstone projects, and they are all graded. Yeah. So any question you can type in the chat. Okay, so I presume many of you, if you are interested, you might be looking at part-time study, okay, or full-time study if necessary. Yeah. So we have actually this thing called structured route. That means you apply to be matriculated from the very beginning. So for part-time program, you will have to spend 2 years. Okay, 2 years. For the first year, you will spend the 2 semester in the year to complete the 2 graduate certificates, the 2 in yellow. Okay. Then for the subsequent year, you do 2 specialist certificates. So you have to make choices, and following our schedule. So you just cannot randomly pick any 2. Okay. So for example, in the first semester in the second year, you choose among the product cert and the security cert. Yeah. Then for the last semester, you choose between big data and the smart cert. So in fact, smart cert is where the IoT topic is included. Okay, so if you are interested in what Dara talked about, then you would want to go for the architecting smart system cert here. Yeah. So second year, as you can see, for the part-time students would be heavier because you also need to do the capstone project. Yeah, and that could last from 6 months to more, to up to 12 months actually. Yeah, so we let the student teams manage their time actually. Yeah, so for those graduate certificates with exams, take note, for those in the first semester, semester 1, exams would be in May. Okay, And for those graduate certificates in the second semester, exams will be held in November. Yeah. So if you want to consider studying full time, then we would have to compress the schedule to just 1 year. Okay. So over here you can see in the because the program start from August, yeah, for full timer, yeah. So for the first semester, you will complete the 2 foundation certificates, and for the next semester, in fact, in 3 months' time, January to March, you complete 2 specialist certificates, and you can see the exam timing as well. Yeah. So for full-time students, you have to do, instead of capstone project, you have to do an internship in as a team, okay, in a local organization, in fact, in the industry. Yeah, although we will still consider uh, any foreign internship, but by default, it will be local in the industry. Okay, so quickly, what if you are not considering following the structured route? Then we have this flexible route where you don't need to be matriculated first. Yeah, so you can, as a public student, join our various certificates in whatever order. Okay, it need not be cert 1, 2, 3, 4. It's up to you. And for each cert, you can plan your own time. You sign up to attend our uh, public courses. Yeah. And you also arrange for when to do the practice module. Okay. And there is a time limit. We allow you up to 5 years to complete your certificates and 2 more years for capstone project. Okay. Yeah. So in general, what kind of participants are we looking for? Uh, these these are the general requirements. So if you want to be matriculated first, that means following the structured route, we expect you to have a engineering or science degree, okay, bachelor's degree, and in general with a CAP of about B, okay. Yeah, but if you are coming from the flexible route, that means you attend our courses as a stackable students, and you do the graduate certificates. So we will expect B minus. Okay, that is about 60% of your CAP. So that will be checked when you apply to be matriculated uh, and join our capstone project. Yeah. Okay, so we need you to have some IT work experience, but we will certainly consider your experience, and then if you make the applications, okay, there will be an entrance test and also interview. Yeah, so that is the general requirements. Yeah. Okay, so if you are interested, right now we are in the process of recruiting for the part-time students starting in January 2023. Okay, so we have the application deadline is mid of September right now. Yeah, so and if you apply earlier, we will arrange the entrance test earlier and interviews earlier as well. So we will not wait for the end. Yeah. Okay, so I hope that give you a good idea of what are we trying to do. Okay, and then also what sort of training are we provided? Are we providing? Yeah. So essentially, we want to train our students to be some form of architects, whether you are solution architects, you are security architects, you are product engineers, product managers, but they must also be good software engineers. Okay, so that's why we have emphasis on software design, software architecture, and then the various specialization as well. Yeah. Okay, so thanks a lot for attending the brief sessions on MTech SE. Yeah, and we certainly hope whoever interested to be applying to our program soon. Yeah, and thank you so much for joining us, Dara and Bunkui here. Thank you.